Put it in the oven. That's right. I could just imagine me being like, honey, I lit the side of the house on fire. Don't worry, I put it out. All right, so we have two type of sequences now. We're going to have arithmetic, which means what kind of sequence? You remember? Huh? Continuous. What did we do to when we did that? How are they? What are each number separated by? This is old. That's from a while ago. The same thing. So that went 3, 5, 7. It would go 9. What do I do each time? Add. So this is addition. Okay, some kind of addition is happening from one number to the next, and it's got to be the same addition. And then geometric. Anyone want to guess what that is? Multiply. Yep. Okay, so some kind of multiplication between each numbers. So in this one, it says, is the sequence arithmetic or geometric? I don't know why they came up with geometric for the multiply one, but that's what we're going to go with. Okay, so first thing I want to ask is, if this is being added, I would be saying I'm adding 1.2 to this. And then if I add 1.2 to this, does it give me the next thing? The answer is absolutely not. So then the next question is, am I multiplying? So really, from one number to the next, it should be the same thing no matter where I go from here to here or here to here or wherever. So if I want to figure out the opposite way, I can just divide. I don't need to divide this one. I can say that that's being multiplied by 2.2. And then I can go to the next one and say, well, what is 2.2 times 2.2? And it gives me that. So far it looks like it's working. And then if I times that by 2.2, it gives me that one. And just for funsies, it gives me that next one. So this is an geometric. And then how could we explain it? How do we know? I'd say because it multiplies by 2.2 each time. And that was nice of them to start at 1 there for us. This next one, I don't know, is it going up by 74 each time? So 1 plus 74, 1 plus 74. We all know it's 75. And then if I add 74 to that, 149 plus 74 plus 74. Okay, and then that's working out to be arithmetic. Because it is adding 74 each time. Are these coming back to us a little bit? Yeah? Okay. So here are the two types of formulas for geometric. And I think one thing that happened last time is we weren't really sure what we had to fill in the formula, and sometimes we'd fill in things that we weren't supposed to. So in the recursive, we need to fill in, we need to know what R is, and we need to state what A sub 1 is. And the rest of it is just part of the formula. So that it's going to be A sub n, some number times A sub n minus 1, and then A sub 1 should be something. So an example of this, of a recursive one, is a sub n equals, give me any random number, 2, a n minus 1, and then I'm supposed to state what a sub 1 is. Give me the random number, 4. Okay, so that would be an example of that formula. You have to give me all of those parts. On the test, I think last time a lot of us left off the a sub 1, but you have to give me all of that. And then the same formula, but in an explicit form, would be still a sub n equals 4 times 2 to the n minus 1. So again, we're going to fill in what a sub 1 is in R. And that would be explicit. And it doesn't have a second part like the other one does. So for really to figure these out, I need to know what R is, and I need to know what a sub 1 is. And in terms of like the arithmetic one is a lot like y equals mx plus b, or a linear equation. So you had to know the slope and the y-intercept. Same with this. We need to know what is the multiply the ratio, okay? And then what is the starting place? What's the first number, okay? So what recursive formula describes the geometric sequence? So I think we're supposed to be writing the formula. So the formula, we're supposed to say a sub n equals, what is our change? Well, all I have to do is go here and say, I know 8 became 12. So if I go backwards there, I'm multiplying by 1.5. So my R is 1.5. And then I'm supposed to write that, give me the term before it, and I can tell you the next one. But don't forget to tell me where we start. We start at 8. Okay, easy peasy. And I remember recursive always means like reverse, like the one before. So this is the one where they just tell you what the one before is to figure out the next. What is the 12th term of the sequence described? Initial condition is 3. Recursive formula is an equals 6 times a sub n minus 1. So I don't know about you, but I really like the other formula. So the other formula would be a sub n equals, it starts at 3, and then it's going to be 6 raised to the n minus 1. So what is the 12th term? All I got to do is go to my calculator, and I go 3 times 6 raised to the, and I could write in 12 minus 1, or I could just do 11. It's so much easier?
Yeah.
How so?
It just seems easier.
Than when we did it the first time?
Yeah.
Okay. So then we get that large number, 108,839,1168. Easy peasy. We good? Honestly, the hardest part I think with these sometimes is just remembering the two different types of formulas. Okay. The number of people attending the festival is decreasing 20% each year since the first year. How can the attendance be for the first 5 years be modeled? So in other words, a sub n equals, And our formula says, where do we start? Okay, if I go up here, my formula says, where do we start? What's our first year?
1,250.
So it's over here in our poster, 1,250. And then what's our rate? If it's decreasing 20%, how much are we keeping?
80%.
80%. Really? That's really the 1 minus the 20% is that rate. So really we're keeping 80%. I don't really need that 0 there, but I like it to kind of illustrate that it's 80%. And then it's going to be raised to the n minus 1. So there's our model. And then it says what's going to happen in 10 years. So they're saying what is a sub 10? So 10 minus 1 or 9. Some of you I'm noticing are starting to put this into Desmos graphing. This should just be like the Desmos calculator. I notice every year students do that. I'm not sure why. And then we would expect about 168 people.
Teachers, if you have not done your attendance, please go ahead and do so at this time.
I don't think I did mine. All right. So really, yeah, knowing these two formulas, what is our R, what's our rate, and where do we start? Okay, so let's move on to the next page. The formula is a sub n is 1.5 times a sub n minus 1 with an initial value of 40, describes the sequence. Use the explicit formula to determine the fifth term of the sequence. So we could say the first one's 40 and then work them on out. When it's the fifth term, it's not that big of a deal to figure that out. But if it was the 15th term, it might be easier to do the other. I always like the explicit formula, which says a sub n equals, where do we start, times 1.5 raised to the n minus 1. And if I were to plug 1 into this, 1 minus 1 is 0 up here. 1.5 to the 0 is 1. 40 times 1 is 40. So I like to sometimes just kind of plug in a value just to make sure that it actually gives me the starting value. Okay. Determine the fifth one. So a sub 5 is 40, 1.5 times 5 minus 1 or 4. And again, that's calculator. And we get 202.5. Remember how challenging these were when we did them last time? Did they feel easier this time? Last time we were just kind of like, it was so different writing. Given the first term and the common ratio of geometric scenes, find the first 5 terms and the explicit formula. So make sure on the homework that we read the directions. So the first 5 terms, so it's going to go 16. And then I take that number, 16, and I'm supposed to times it by negative 0.0 or 0.5. Get negative 8. So anyone tell me what the next one is? And I'm going to times that by negative 0.5, get positive 4. Anyone know what the next one is? Negative 2. And then the fifth one would be positive 1. Good. So there's my first 5 terms. They want the explicit one. That's the one I like. And remember, explicit with like music, it means it just gives you the full version. I like the explicit one for geometric sequences because it just gives you the nice formula that we need. Where does it start? Starts at 16. What's our ratio? Negative 0.5. Do you guys like putting that 0 in there? I don't particularly like it either, but it wouldn't be wrong. N minus 1. Again, I like to plug in 1 just to kind of make sure that my brain's working right. If I plug in 1 here, that becomes 0. That becomes 1, and that does give me that first one, which is 16. The next one, 3.5. Our rate is 2, so the next one would be 7, 14, 28, and is that 52? 56. Just kidding. Someone want to tell me the explicit formula? Yeah.
A n equals 3.5 parentheses 2 to the power of n minus 1.
Brilliant. Morning. Were you guys on a bus?
Yeah.
Oh my goodness. Did you check in the office?
Yeah.
Okay. Here's the notes, guys. Thanks. Is Texas A&M the team that beat LSU this weekend? Huh? Yeah. All right. Given the first term of the common ratio of a geometric sequence, find the recursive formula, the one where they tell you what's the one before it, and the 3 terms in the sequence after the last one given. Okay, so let's start with the recursive. So recursive says, tell me what I'm going to do to each one. Well, to each one, I'm going to just times it by 2.5. So if you give me the one before, then I can give you the next one. Don't forget, part of the recursive formula is you have to tell me where does it start. Even though it's on there, this is part of the recursive formula. Okay? So there's my first answer. And then it wants to give me the next 3 terms, which I think is kind of weird, but I'm going to go ahead and write 3. And then it wants me to give the next one. So 3 times 0.25, 0.75 times 0.25 again. Gives me that ugly number. And then do it one more time. Oop. It gives me that one. So technically the answer to that are those 3 numbers right there. Should we race on the next one? We get a head start because I'm going to shut the door. Mark's that good. Maybe sharp or shorter pencil. Okay. How'd we do? Did I beat you? This kind of stuff comes up a lot in like programming because numbers represent things in programming. So if you have a R ratio that's -1, it's kind of cool because what does it do each time? Okay. What's the next term do?
Positive negative switch.
It switches signs, right? So in programming, a -2 or a +2, and really with ones more likely. Anyone know what a +1 compared to a -1 does in programming? It's kind of like a switch. Okay. And what would a switch do? What's a switch do? On and off, right? So if you want something programmed, each time it's going to turn on, it's going to turn off. Okay. So, yeah, you got to figure out all these different formulas and how I can get things to go on, off, or make the value -2, then +2. So I don't know. To me, when I see that, I think of like Christmas lights. What do the Christmas lights do when you put the special bulb in there? Huh? Say it again. And then, well, not that special bulb, not the burnt one. You guys don't know about this putting a special bulb in the Christmas lights and what it does? So if you get, you know how you get those like 3 extra bulbs in the box? There's one that's like half colored. It's like red, half red. Anybody? And you take out one bulb and you put that one in, what's going to happen?
Don't they like start going on and on?
They blink. Yeah. So there's a bulb in the box that makes them blink.
Wait, actually?
Yeah. Would I lie to you?
No.
Well, I would, but not about that. But yeah, isn't that weird?
I've never done it before.
Gosh, we're learning a lot today, aren't we?
Yeah.
Anybody deep fried turkey this weekend? No? Okay. All right. Before you guys got here, we had a full discussion about deep frying turkeys. What did we learn about that? Yeah. So what should you do?
Don't deep fry them.
Don't deep fry a turkey.
You can.
You can.
I mean, you
You can, but just don't.
My cousin did it.
Yeah.
He
He didn't explode?
No.
He's still alive? That's good. Air fryer. There you go. Okay. Given the terms of geometric sequence and the common ratio, find the first 5 terms, the explicit formula, oh my goodness, and the recursive formula. This is a lot. Okay. So the first 5, and we started at the 5th term. So we want to go backwards. Okay. And we had some problems with this last time trying to figure out what's going on. But if we're going backwards, well, let's just write them out. We're supposed to find the first 5 terms. So I'm going to write them backwards here, 164. The term before that, if I'm multiplying by -2 to go backwards, I would divide by -2. So I get -82. I think I can do the next one in my head. Positive 41. And then a -20.5. Now I'm getting lazy, so I'm going to put this in the calculator. -20.5 divided by -2. I get 10.25. I've got 1, 2, 3, 4, and that's the first 5 terms. Right? Did I mess up? We okay? Okay. So then I'm going to go ahead and give the explicit formula. A sub n equals, where do we start? 10.25. And what are we doing? We're multiplying by 2 each time. -2, thank you. Yeah. Times by -2 each time. Good catch. So there's my explicit. And then my recursive formula would be a sub n equals, I'm going to times by -2 each time. So if I know the one before, I know all I got to do is times by -2. And then for that one, I need to include where it starts. It starts at 10.25. So that's that formula. So there's that answer. That's part of the answer, and that's part of the answer. You want to race on the next one? Take a sip of coffee. Anybody have allergies the last couple days?
Yeah.
You did? I can't tell if I have allergies or I'm dying.
-5.
7.5 times 0.5. Do you want me to do that for you?
Yeah.
Oh, I went the wrong way. I need to divide, right? Dividing by 1/2 is the same as multiplying by 2. So third term. Did I do okay?
Why does it sound like that? It sounds so weird.
Strawberry lemonade.
What are the blue boxes
Ready for the next set? Okay.
What?
Given the two terms of geometric sequence, find the 8th term and the recursive formula. Okay, so what we got to kind of figure out is what's going on between each of these. So this went 3 times, and in 3 times it did, again, it's multiplication. So 1, 4, 5, 8 divided by -54. So -27. So I'm going to kind of just put my thoughts down here. 3 steps is -27. So what is 1 step going to be?
-9.
Say again?
-9.
It's not -9. So what am I multiplying? First off, it's pretty clear to me that it's got to be a negative, right? It's the only way we can get them to switch. So what am I multiplying by that I did it 3 times and that resulted in 27? 3. Does that make sense? Because 3 times 3 times 3 is 27. Another way of considering it is I need to figure out, and I think we know this math, that's the third root of negative 27. Where'd that 3 come from? Where did this 3 come from? Ms. McConnell? Sure. Bye. Aiden, as soon as we're done with these notes, we'll go down to Mr. Allard or Allman. Okay. So this 3, just so we're clear, is this 3 right here. Okay. So that's that 3. So if it was 6 steps, I would have done the 6th root and so forth. Okay. So that means now I can figure out the 8th one, and I can also figure out the recursive. So the 8th one, how do you want to do this? Well, we're at 6. Should we just go 2 more? So 1, 4, 5, 8 times negative 3 times negative 3. There's the 8th one. So the a sub 8 equals 1, 3, 1, 2, 2. Cursive formula is a sub n equals, we're multiplying by negative 3 on each step. And then we have to say what our a sub 1 is. So I have to go to this one and go backwards 2. So if I know that my ratio is negative 3, then I can go to negative 54, and backwards means undoing would be divide. That gets me to the second. Divide by negative 3, that gets me the first. So that's negative 6. Again, making sure we realize that the recursive formula, we have to give 2 parts to that. And that's why that formula is so annoying to me. Okay, how about the next one? Well, we went 2 steps was negative 640 divided by negative 160. And that's 4. So if 2 steps is 4, then what is 1 step? Then 1 step would be 2. And you could have done the square root of 4, right, to get that. So then that means we're at the 7 one. I can figure out my a sub 8 pretty easily. So negative 640 times 2 is negative 1,280. Why isn't this negative? We have negatives in our problem. Why isn't that negative? Okay, because then it would make it positive. When this is negative, that makes it alternate, right? But in this situation, we don't necessarily know that it's alternating, okay? But we can kind of assume. It actually wouldn't be wrong to say that it's alternating because we don't really know, but we should just assume that they're both negative, then that's meaning that it just stays negative. So there's our a sub 8. A sub n equals, our rate is 2 times whatever the previous one was, and our a sub 1. So we got to go back from 5. So I have to undo this 2 until we get to 1. How many times is that? We got to be kind of careful. Can anyone tell me how to do it in 1 step? We got a sub 5. I want a sub 1. How many steps backwards am I doing? 4. So I have to divide negative 160 divided by 2 to the 4th power. Good. So that's negative 10. We really didn't need to know that because we could have just taken those steps back. But if this was like 27, we wouldn't want to have to do 26, 25, 27, and so forth. Okay. A mistake that I would imagine people would do is they would take this back 5 times. We don't want to go back 5 times. We want to go back 4 times because we want a sub 1. Okay. Easy peasy. I think you could probably knock out the first 6 problems pretty easily. If you want to jump on that.